Hello, everyone, and welcome to 321 Gang's webinar, Software Reuse in Automotive Engineering. My name's Kara Rawlings. I'd like to tell you a little bit about 321 Gang before we dig in. 321 Gang are a Platinum IBM business partner and a scaled Agile training partner. The Gang are the continuous engineering experts and an industry leader in scaling lean and agile practices. We offer our clients expert IBM and SAFe consulting services, training, and software tooling solutions to accelerate and drive results in the most complex, highly regulated systems and software engineering environments. 321 Gang's engineering expertise can help, whether you're facing regulatory, economic, technological challenges, whatever you have in hand. 321 Gang offers industry-focused training and consulting. Talk to us today and learn how we can help you deliver the solutions your team needs. Please take note of the question box in the control panel. We'll be accepting questions throughout the presentation and we'll be addressing them at the end. So today we have Brett Hillhouse and Peter Leckie as our presenters. We also have a demo that will be delivered by Andy Lapping. So I want to tell you a little bit about Brett. He's a global automotive leader for IBM AI applications. His responsibility includes industry and technology strategy, as well as customer success for automotive companies around the world. His 25 plus years of industry experience includes transformation engagements at global automotive and aerospace OEMs and tier 1 suppliers. The scope of these engagements includes transformation of product development, reuse strategy and implementation, manufacturing 4.0, supply chain management, and compliance consulting. Previously, he has held several industry and leadership positions at IBM and Siemens, formerly SDRC. Brett holds a BS in Mechanical and Aerospace Engineering from Cornell University. So 321 Gang's Peter Leckie is a Senior Solutions Consultant here. He is a Scrum Master and a Certified SAFe Program Master. He received his master's degree in Computer Science from Purdue University. Peter began his professional career in IBM's Federal Systems Division as a programmer, where he concurrently worked as an adjunct associate professor at the State University of New York Binghamton, teaching software engineering and publishing a number of papers on the subject. Upon moving to Canada, he became the technical manager of IBM's Rational Software Development Environment for Rational Canada. Peter has been involved in selling and supporting engineering tools and the processes supported by these tools throughout his career. These processes include topics such as Agile, MBSE, and SAFe. And that concludes the intro. And Brett, the floor is yours.
Great. So what I'm going to do is walk through a lot of the business background on the why and the how of software reuse, and specifically in an automotive example. Andy unfortunately can't be here live, so we have a recorded demo of his, but Peter will be here to be able to answer any technical questions as well for afterwards. Please feel free to put questions into the Q&A as we go, and I can try and answer them as we go, or we will definitely take some time at the end for a longer Q&A session. So with that, I'm going to go ahead and get started. We know that there's a lot more complexity in the vehicle. We know there's a lot of changes going on in the vehicle today. I was lucky enough between Delta and Omicron to be able to get out and see a few clients, and one client I was able to meet with was the head of engineering for a very large Asian automotive company, put it that way. We actually were able to have dinner. Over dinner, we talked about all the challenges that were going on in the environment and everything that's happened, whether it's COVID or whether it's supply chain issues or it's just one thing after the other. And he said, is there one thing that stands out over the last 5 years that was just the most complicated, the worst thing? Things have gotten worse. And he said, I've had the same answer to that for the last 5 years, and the answer is the worst thing that's happened. It's happened today. It always gets more complicated. There's always something new. There is always a new challenge to be had. So a lot of changes in here, and a lot of different issues that are coming from it are definitely related to the software side of things. So what can we do about that? So one of the things that we talk about is that it's not just that those challenges are there, they're manifesting themselves in ways that are negative to the OEM and tier ones. So we know that there is just significant more breakdown of vehicles, of defects in the software, and it's affecting everything from warranties to recalls. So in addition, with this move to electrification, there's a move to a new type of architecture on the vehicle as well. And this is an interesting element here, that when I start to work on the software that I had in this spaghetti wiring looking one on the left, the software is pretty simple to be able to write. I had a dedicated wire to from a single ECU to a dedicated sensor and another one to a dedicated actuator. That software is pretty easy. I probably don't have unique IDs on the signals. I'm probably not doing any sort of memory buffer checking. I'm writing that thing and I'm just doing it quickly and dirty as I can, and that code runs great in that environment. If I just take that and plop it into where we're headed with zonal architectures, it doesn't work well. That's why I'm saying that this order of magnitude change in complexity is happening even in just this one area of moving to this new type of ring-based architecture, because all the software now starts to interact with each other, often in unexpected ways. I don't know how many of you have, I mean, there are vehicles been, very clearly outlined that when you roll down the driver's side window, when you happen to have the driver's side climate control on, it pops open the trunk. All right, so that's kind of a benign example of software interacting in unexpected ways, but this is truly a safety and security issue as well. Even things such as the memory buffer one that I mentioned, you should be looking at what the data is coming back. Is that what I expected or not? Or is it something different than I expected? That's a classic way of getting in there and hacking through a vehicle. We've seen that happen, get into the CAN bus, everything, just through a simple memory buffer overload. So complexity goes up, the liability's up. They've really got to change the way we look at software and are developing software on the vehicle. So what does that entail? I try and look at it in three different ways from the business perspective. One is, of course, we're looking to increase quality. And there are a number of different approaches that we can take in that, including really leveraging some of the best practices that have been put together around ASPICE, in that capability of doing a systems and software and other disciplines tied together in an actual process here that has seamless processes and tools and data. So that's a big area for us, and moving to Agile is often part of that from an on-time delivery perspective. And I will argue that reuse is one that impacts all of these. So when I say, maybe increased reuse is a business goal, you might think a little odd at first. But these OEMs have been doing this for a long time in tier ones, that they are increasing reuse of their mechanical components. Example is Volkswagen MQB architecture. They have a single base architecture for their vehicle across 25 different nameplates globally. So they're already doing this from a mechanical perspective. Our focus here is really to try and explain what that means in software and what are the types of results I'm going to get from doing this around software as well. I already know the mechanical side. Now I got to take a look at this from a software perspective. So when I look at what reuse means across all these different areas, it's helpful to have kind of a maturity discussion about where companies are, and this is really to have the conversation amongst yourselves as the company, that where are we in our process of being able to do parallel development, for instance. I find most companies are somewhere in this process-driven area today. Some of the outliers are definitely getting into product variants and product line engineering, and I'll explain a little bit more what we mean by these different terms a little further on before the demo. And so it's basically, though, that I'm going to go and start to look at how I'm doing reuse, and am I doing the typical industry approach today, which is clone and own. So I have an existing project, I take that data, I put it over in my project space, and I start working on it. The problem with that is it very quickly does not scale because it gets out of hand. Who used what feature for another program? What changed in that feature from the other program? Is that something that was a bug in the other program? It gets out of control very quickly. So this copy and paste, clone and own is something that most companies are trying to get out of and really starting to manage variation with branching and merging. This has been common in the software code environment. It has not been as common across the rest of the engineering artifacts. So being able to branch and merge across your requirements, across your models, across your code, your test cases, test results, being able to manage that kind of a process amongst all those different engineering artifacts is what's really critical here. So being able to do that effectively is step one. Another step is where I get into component reuse. And this one we're seeing a lot that just adds a tremendous amount of value. And often this is the pinnacle where a tier 1, a tier 2 supplier is going to go. They're probably not going to go all the way to the feature modeling at the bottom. And what this allows them to do is look across their 5 largest customers and say, I'm going to create a platform based upon what is 80% in common. That's kind of the approach we're seeing on those. And then they have these reusable subsystems that they can swap in and out very simply and easily. And then finally, there's the parameterized reuse or feature modeling. Now, we're not going to have this in our demo today. That's a subject for another day. But when I get into parameterized modeling, what I'm basically doing is doing a tops-down approach, where I look at my base product and I say, what are all the different variations I'm going to have and where are those variation points held? And then I'm going to define all of those. Right, so tops-down model, I'm going to do a work breakdown structure from a feature model, and I'm going to manage that over time, okay? Those are really kind of the 3 different areas of where we see people at. And we're going to spend some time on both the top one and the middle one, especially today. So what I'm going to do here is just talk a little bit about what we mean by this branching and merging, because I think this is not always well understood, that a branch and a merge or a branch is not necessarily a bad thing as long as you understand how you're going to be able to merge back. I've definitely been in environments where executives are saying branching is bad, branching is bad. That can be a goal to have fewer branches, to reuse what you have, but branching because I have a new capability that I need or I want to try out a new functionality is just reality. And I want to be able to, then to merge it back into my base platform at times, or from model C to model B. So I'm going to want to be able to move these things back and forth on this capability. So again, this is a model that's been used in the software world for a long time. We're beginning to apply this in a much broader context here across all of the requirements, the models, the code, and the tests, okay? We call it something called global components and global configurations. That will be in the demo. I'll show you exactly how we use that. Over time, you take one of those components and you have a stream associated with it. So these are the 4 different streams for it. I then can start to look at how am I going to baseline a single configuration across all this area. So what is the baseline across a specific program that I'm going to pick? It's on this requirement with this level of the model and with this level of the code with these tests associated with it. That allows me to group all this together and really create a reusable component that I can use in multiple different programs. So these baselines are really important. They're a little more complicated than this typical code one because I'm dealing with it across 4 different areas. 4 different types of artifacts that I have in the system. And then really what I can do is start to say, okay, now that I've grouped these and I have a standard cruise control approach, I've got, perhaps these other versions of cruise control that I can swap in and out for a specific customer or a specific program. This is really powerful on being able to, upgrade over time. You might build something once for Mercedes and you realize later on Ford's coming up with the exact same requirement for that type of feature. You can very quickly and easily be able to slide that new version in without having to do all the re-engineering of understanding where are the requirements associated with it, all of that. You're really only having to look at the interfaces between the cruise control and the above consuming area of the bucket where you put that cruise control, like in the ADAS system. So the interface between the cruise control and the ADAS becomes the critical factor. The other thing that we like on this is that we're starting to see a lot of these IT concepts that have been around a long time, such as containerization. That's starting to come real in the vehicle OS, as well as the idea of being able to very quickly or easily do over-the-air updates to containers. So think about this. Can I not only swap out a function, a capability on the vehicle, some software, but I can now swap out and put in a newer function in the vehicle very quickly and easily because I understand how Cruise Control 1.6, version 1.6, is going to fit in this particular program, and I can just quickly add it in. So there's a lot of advantages, even over time, not just the first time you do this, but over time as you do over-the-air updates on how they can be leveraged and increase the functionality in the vehicle. And so, the idea here is that once I swap out that cruise control, I'm only having to look at what is different in the interface between that cruise control version and the ADAS and ADAS model year basic with what the new cruise control version is. That means I may have to do some testing, but I may not. If the interface really hasn't changed and the functionality is all controlled inside of the cruise control module, it means there is no additional testing going on. That is extremely powerful. So the idea here is that I'm not having to retest the whole system every time. I'm not having to retest those components every time. I'm only having to look at what the interface is between these and how they interact. Okay? And again, this same approach, whether I'm doing it from that 80%, in common view that we have that might be more appropriate for a tier 1 or a tier 2 supplier, but it's the same kind of approach that you use as you get into doing it at an OEM level where you might have more of a tops-down approach. Okay, so this is complicated in a way, right? I mean, this is not always the most simple thing to explain, and it is different than just saying, hey, reuse this component and I'm done. That's the mechanical world. It's not about just reusing the software, but the advantages of this are very big, and they can be just amazing what you see here. So these are some real world results that came from General Motors that published years ago on what their savings have been on doing a reuse approach. And so I've not adjusted these numbers or the charts at all because they were not mine, but I will explain them what some of these small print is here that we have. The first two lines on the top left here under normalized engineering costs is essentially the same piece of complex software code that went for on a bigger, more complex ECU. The first line done without reuse in mind, the second line with reuse in mind. So they spent about 10% more engineering effort into creating it with reuse in mind, with a product line model. Now, the second iteration, that's the second set of lines on the left there, is the next iteration of that design. I added a new feature, I made it a change. Now I see a 6x decrease in engineering effort on that second iteration than I did on the first one, and then I did on doing it without reuse in mind. That is extremely powerful. That's where a lot of the engineering savings comes in right away. Now, the second sets of lines are much more simple software, simpler ECU that I had put together. More than double the engineering effort, but still a 3x savings on the next iteration. And across most industries, there are plenty of studies on this reuse model that it's usually about 2.5 iterations is where the break-even point is. So if you're doing something that's clearly just a one-off, you may not have to build it with reuse in mind. But if it's going to be reused, if it's going to have iterations, more than 2 of them, you definitely, the savings are huge. So it's not just engineering effort, there are other issues that downstream that are associated with it. So there are other engineering costs. For instance, if you want to have the same software everywhere, that means when you buy a cruise control switch as an OEM, you got to make sure that cruise control switch, the software with it, supports a 5-volt and a 12-volt control system. It also has to support a sliding switch on the column and a momentary switch on the steering wheel. That way it's the same software in every switch on every vehicle globally. That's how you start to do that. Now, that impacts other parts of the business, right? Procurement's got to be on board. And by the way, procurement, of course, loves reuse. That they're one of their highest things. They want to reuse stuff. So the idea of doing this with software, they'll get it. The normalized warranty claims is the other thing that you see here. So clearly, huge savings in, having that same software everywhere because you've tested the heck out of it. And yeah, there's, the problem is, I guess, if when you do have a problem, it's everywhere, but you've really tested the heck out of it, and they saw their claims go down very specifically that this was the main change they had made, and boom, they saw this kind of savings across the board, okay? So why don't more people just do this? Well, I'll come back to this at the end for the Q&A. One of the things that I want to mention up front is that organizational alignment is really important. And what Conway's law states is that essentially your organizational structure will be reflected in the architecture of your product, okay? So if I'm an organization in automotive and I am organized by mechanical parts, we do this body controller, we do this lighting controller, we do this, other ECU, well, it's going to be very difficult to get these teams to work together and reuse software across these areas. And what we're seeing is the whole industry has been changing to address this. So we're seeing software organizations at the OEMs and the tier ones over the last 2 to 3 years, a ton of changes out there. So this to me is the number one thing that's got to be done, got to get right, is that it will be very difficult to do if I don't get the organizational structure right. In fact, Ford, one of their recent reorgs was called Project Conway, very explicitly calling this out, okay? Again, I think I'm going to go ahead and get to the demo piece. I'm going to explain just briefly here, and then we'll come back to this slide and get some more questions, and I'll try and walk through some more of those areas. What we're really going to walk through here, what Andy has, is looking at these 3 areas of change management, parallel development, and product variants. That's what we're going to cover on here. We will not, as I said, get into the tops-down product line engineering and modeling. That's a piece that we save for another day, and we have partners that really do that piece very well integrated into this same process. Okay, so with that, I'm going to go ahead and turn on Andy's demo.
Okay, so let's actually start first of all with the product. What you're looking at here is the product breakdown structure for a vehicle platform. At the top, we have requirements and we have qualification tests for the entire vehicle. All right, that's then broken down into powertrain, ADAS, chassis, and so on. Now, if I expand out powertrain, the powertrain has a set of requirements and models now and tests, and that is then further broken down into transmission and engine. If I look at ADAS, that has again a set of requirements, models, and tests, and is further broken down. If we expand the adaptive cruise control subsystem, that has requirements, models, and tests, and actually at that level, it also has some source code. Now, as Brett mentioned, we can reuse artifacts here at the global level, at the component level, right, which we'll see a little bit later. But we can also reuse artifacts locally. We can start small. We can do that in the domain tools, which is where I'm going to start. Now, I'm going to use requirements management to demonstrate this piece, but all of the other domains have similar capabilities. So let's open the requirements for the adaptive cruise control system, which we can do by simply clicking that part of the product structure, ACC requirements. All right, we've now moved into the requirements management part of the platform. And as you can see, we've got a lot of different modules or documents of requirements, and these things are all at different levels. Now, I'm going to open one of those, so that one. And that one details the hardware requirements for a range sensor ECU. Right at the top, we have a bunch of requirements around CAN bus, HD converters, and so on. I'm going to select one of those requirements. It's one about a 12-volt power bus. Now, when I select that, over on the right, we can see where that artifact is used. So it's used not only in this document, in this module, but it's also used in two others. If I click one of those links, that's going to take me to that document, to that module. You can see that requirement is now highlighted here in that module, detailing the requirements for a cruise control ECU. But it's the same requirement. So if I actually edit this and we change it right here, I will change that to be a 5-volt DC power bus. If I then click on that link and go back to the range sensor ECU requirements, you can see it's actually changed there too. Requirement reuse is baked into the platform. So no more copying and pasting of requirements, no more clone and own, and all of that overhead that comes with it. Okay, so how do we actually control that change? Let's move on. In fact, we're going to move on now to that maturity curve, because one way of managing change is baselining, the first level on that maturity curve. Now, the ELM platform has two concepts. It has streams and it has baselines. Now, streams just means that it's mutable. We can change things over time. Streams then have baselines, which freeze the state of the artifacts at that time, so we have a known configuration to come back to. Now, those things, those streams and those baselines, they exist both at the local level here, but also at the global level, which again, you'll see in a few minutes. Now, notice right at the top here, we have a button that shows us the current context. Are we looking at these requirements? Are we looking at a stream or are we looking at a baseline? Right now, we're looking at these requirements in the context of the vehicle program platform global stream. If I click that button, you'll see that global stream here at the top, but underneath it, you'll also see what the corresponding local stream is here in the domain tool. That's the ACC requirements stream that we clicked on to actually come here. Let's actually open that local stream. Here, we can see any existing baselines that the stream has. In this case, we just have one, this version 1.0 baseline. If I open that baseline, and then I choose to explore it, and again, we have the same folder structure here. We have all the same modules of requirements. And I can open that, we can view those requirements, but at the top, you can see that current context has changed. We're now looking at these same requirements in the context of that version 1.0 baseline. Also over here, we've got a message telling us, hey, artifacts in a baseline cannot be changed. These things are actually all read-only. Hover over that, you can see it's actually not editable. Well, we can compare streams and baselines to other streams and baselines. For example, let's compare this baseline to the current stream of work, which was that ACC requirements stream that we clicked on in that global product structure. That invokes a little wizard. There's various aspects to this, but I'm just going to page through to the end where we see the actual fine-grained detail. Now, I created that baseline before the demo, and since that baseline was taken, there actually only has been one change, and that's the change that we just made. You can see these changes in great detail if you want to. So that 12 volt got changed to a 5 volt between the baseline and where we are right now. Now, when we're working on requirements or any of the other artifacts, models, tests, doesn't matter, we can switch contexts directly from this current context menu. For example, right now we're looking at the baseline, but if we want to go back to that team stream, vehicle program platform, then we can do that straight on that button. Likewise, if we want to create a new baseline, we can do that from the same menu. So let's create a new baseline of this stream that we're working in. Right, let's give that a name, call it the ACC requirements version 1.1 baseline. I already had a 1.0, we'll call that one 1.1. We've now baselined that stream. If we go back to the local stream, then you'll see that new baseline there in the list. Now that's streams and baselines here at the local level. But as I mentioned, they also exist at the global level too. So let's go back to our product breakdown structure. Now this vehicle program platform at the top is a global stream, as is powertrain, as is ADAS, as is ACC, and so on. Now we actually have a more general name for them. We call them configurations because these could be streams or they could be baselines. Now these global configurations organize all of the local configurations from the domain tools underneath them. That's important for a number of reasons. Firstly, it handles the links, it handles the traceability. As you'll see in a few minutes, all of the local tools can have multiple streams, and those might represent things like geographical variants. They might represent model years and so on. And when you're working on, for example, a set of requirements in the context of one of those streams, it's this global structure that makes sure that you're seeing the right set of linked artifacts. You're seeing the right set of models or the right set of tests for the variant that you're working on. But this structure also allows for some very powerful automation and also reuse at the global level. Let's start with automation. I can take this vehicle program platform and I can actually baseline the entire thing with a single click. Let's give that a suffix, we'll call it version 2. And at the bottom, you'll see what's going to happen. 23 new baselines are going to be created. So we'll click OK. Now that automation is now creating baselines. It's going to do that here at the global level for our global streams, but also at the local level too. In every local tool that participates in the product, every requirement, every model, every test just got baselined. That's completed. Over here on the right, we can see that new version 2 global baseline, along with the version 1 baseline that was taken previously. If I open that version 2 baseline, over here on the left, I can expand this tree out again, and you'll see that all of the contributions from all of the domain tools are now baselines. They all have this version 2.0 suffix on them. They have an icon which tells me this is a baseline. And if I hover over it, it tells me this is a baseline. If I open that up, it takes me into requirements management. I'm now looking at these requirements in the context of the vehicle program platform version 2.0 baseline, and artifacts in the baseline can't be changed. But we did that globally. The next 2 levels on that maturity curve are change management and parallel working. So let's do that. Let's go back to our global structure. And we'll go back up to our vehicle platform stream. And this time, let's open up the requirements for the ADAS subsystem. And then we'll open up, again, a module of requirements. Now, notice that at the moment, all of these requirements are editable. If I double-click one, I can actually start editing it. It also locks. You get this little lock symbol over here. If I click away from that, it unlocks. Multiple users can all edit this same document at the same time. And that automatic locking mechanism prevents multiple users from editing the same requirement at the same time, and thus introducing conflicts. But this is really flexible, and it's a common way of working at the start of a project where there's a lot of churn. But let's imagine now that we've reached a milestone. Maybe we've already taken a baseline, and now we want to impose change control to make sure that any changes are documented and that they're only made with the appropriate approvals. Let's again open the local stream. Here and here we can see the options that would typically be set by a manager or whoever's responsible for the project. First, in order to be able to edit the requirements, we have to create a change set. A change set is simply a named collection of changes. That could be a whole bunch of requirements. Secondly, we could lock that down even further and prevent the delivery of any changes to the team, to the stream, unless they're linked to an approved work item. But in the interest of time today, we're not going to use that option. Let's save that, and we'll go back to exploring the stream, and we'll go back to our module of requirements. Now, notice that these things are now read-only. I can't edit these things. And also at the top, I get a message saying, if you want to create or edit or save or do anything in here, you now have to do it as part of a change set. So let's create one. Let's create a new change set. Now let's imagine that we're going to add a new feature. We'll name the change set accordingly. Let's say we're going to add night vision into our ADAS system. All right, having named it, create that. And notice now that the current context has changed again. We're now working in Pete's own personal area. Any changes that he makes are now isolated from the stream. They're isolated from the rest of the team until he delivers them. So we can now make any number of changes that we want to this module. Those changes will all be encapsulated into this night vision change set that we've created. So let's do that. Let's go and make a few changes. I'm just going to select one of those requirements, double click it to edit it, and I'm going to hit Control Enter to add another one of those things. So I'm adding another section. I'll call it night vision. And I'll hit Control Enter again, but I don't want a heading this time. I want a system requirement. And we'll say the system shall have night vision. We'll hit Control Enter again, and the system shall have more requirements. All right, we could add as many requirements as we actually wanted at this point. We can now go ahead and deliver that change set. Of course, if we had change control imposed by our work items, we'd be prevented from doing so unless we've got a work item linked to it that actually had approvals on it. Now here we have a whole bunch of different options for change set delivery. We could, for example, have multiple change sets. We can choose which ones we want to deliver. Delivering multiple change sets might introduce conflicts, so we have conflict resolution options. In our case, we're just going to select Express and then just simply deliver that change. If we now switch from Pete's own personal area back to our vehicle program platform that we started with, now the rest of the team can see the same set of new requirements for night vision. That's change control. Now for parallel working. Let's go back to that local stream, ADAS requirements. And I'm going to go to the Streams tab because there are actually 3 local streams here. There's one for the full set of ADAS requirements. Right, we can consider that to be the 150%, the luxury model that has all of the features. And in our naming convention here, we've used no suffix for that. So we just called it ADAS requirements. But underneath that, we've got 2 other streams. And as indicated by their name suffixes, one is for a basic or economy model, and then there's one for a mid-range model. And we could have teams working on all 3 streams at the same time. Let's open that basic requirement stream, and we'll explore it. And again, we'll open up the module of requirements and take a quick look at that. Now, it does look roughly the same as the platform requirements we were just looking at. But again, we can compare. In this case, we'll compare this basic stream to the ADAS requirements platform stream that we started with. Again, we've got that wizard. We can page through to the end, go to the module, and we can see the differences. Now, our basic set of requirements doesn't have night vision, of course, because that's a feature we only just now added to the platform set of requirements. But down here at the bottom, you'll see there are other changes too. So our basic model has no requirements for lane change. It has no requirements for parking assistance either. So let's get some reuse at this level. Let's actually take those night vision requirements we just created in the platform, and let's reuse them in this basic model. So we'll go back to our module, and we'll go back to that context menu. Now here we can pull or we can push. We can deliver changes to other streams, or we can accept changes from other streams. Now, since we are currently working in the basic variant, let's accept changes We'll accept them from that platform set of requirements, the ADAS requirements stream. Now here, if there were multiple change sets, we could choose which change sets we wanted. Of course, in our case, we only have that single change set that we just made. So we'll select night vision, we'll add it to the list of things that we want, and then we'll actually enact that. And now we're still working in the basic requirements, but that basic requirements now has the night vision feature. That's reusing artifacts locally. That's reusing, in this case, requirements across streams or across variants. We can also reuse entire components, entire sets of requirements and designs and tests, all hierarchically at the global level. Let's go back to our product breakdown structure. And again, think of this vehicle program platform as the luxury top-of-the-line model. It has all of the requirements, all of the models, all of the tests for every feature. And if I go up to this component, you can see there's actually a variant of that vehicle, the economy vehicle. If we open that, and then I expand something like, say, ADAS, then we can see there are differences. First, the local streams are the basic ones. This is the ADAS requirements basic set of requirements we were just looking at. So that's the stream of requirements representing the basic set. But there are also actually structural differences here. And we can see that by comparing global configurations. So we can compare this economy structure to the platform structure, and we can see what's different. For example, both of these variants have the same transmission, they have the same engine, but they actually have different powertrains in them. Down at the bottom, they have the same electronic stability control, but the basic variant has no lane assist component at all, and no park assist component at all. Okay, lastly at this level, let's create a new variant. Let's go back to our vehicle program component. We'll go back to our platform stream. And let's now create a new global stream. Call that, let's say, mid-range. We already saw we had some requirements actually for mid-range. I'm looking at the requirements management domain. So we've created this new global stream. And at the moment, all of the requirements and components, everything under here are exactly the same as the platform because we created this stream from the platform. But let's change that, because here we can reuse entire sets of linked engineering artifacts, requirements, models, tests, all by swapping out these components. So let's say we've got a mid-range variant of the ADAS. There we can say, I want to actually replace the one I've got in this structure with one of the others. So there's a basic variant of the ADAS, there's a mid-range variant of the ADAS. Let's choose that one. Now we're reusing, again, an entire set of requirements and models and tests, this time for the mid-range. The ACC actually is exactly the same. That doesn't change. In the mid-range ADAS, the adaptive cruise control is exactly the same adaptive cruise control that's in the economy variant and also the platform. But at the bottom, we have an additional component. We have lane assist in addition to the ESC. So that's reused at the component level. Now, the last part of that maturity curve was full product line engineering, where we build a feature model. And we use that feature model to then control the variation. Now, that we do in partnership with business partners like Pure Variants and Big Lever. So we build the feature model in their tools, and they can then automate the generation of baselines and streams based on variation points that we then embed into the requirements and the designs and the tests.
All right. Well, I hope that made it real, what we were talking about on how we do this. So we walked through, I mean, obviously change is still part of this, streams are still part of this, but how you get to the point where you're starting to actually be able to reuse configurations across those streams. That's where the real power has come in. I think right now we can open up some questions. I'm just going to talk a little bit more about some of the questions I often get. It does take a little bit of time sometimes to explain. I mean, how many of you have, mechanical engineers who run the business? So helping them get a handle on what we mean by software reuse is important. It's not enough to say I'm using the same version of Linux in the head unit with Android Automotive on top of it and blah, blah, blah. That's not what we're talking about. We're really talking about what it is to do the engineering effort underneath it and how you have a very easy swap in and out strategy for the reuse. I also will say that it affects all parts of the business. I mentioned the procurement guys, but in the suppliers and downstream. So it is transformational. It can affect what you're doing from a serviceability and maintenance perspective on the vehicles as well. And then we often get into organizational structures. Do I do reuse and prove it out on a program? I've seen that, but a lot of different approaches that we've seen out there. Some folks are kind of waiting around for their next EE architecture. I won't say waiting. Everybody's working really hard on their next EE architecture. And so a lot of programs have started down this path recently as they started to build out their first zonal architectures in the vehicles and moving to AUTOSAR adaptive in that mode as well. With that, I think I turn it over back to 321 to the gang and see if there are any questions that we can answer.
Thank you, Brett. Okay, first question here. Can you explain more about how clients get started with this type of reuse?
Yeah. So first of all, I would definitely say you got to decide between the 80% or the 150% approach. Do I have a tops-down model, work breakdown structure that I do from the beginning? That's using some of our partners to help do that. Or do I need the 80% model? Typically, I see that delineation is tier ones do the 80%, OEMs do the 150%. That is pretty standard out there. Although some tier ones have the ability to really dictate what they are going to have and what their whole platform looks like. Not common, but it does happen. The single, so the other area that I see is usually justification is not a problem. It's pretty clear that there are tremendous, synergies in doing reuse across programs and across platforms. So they get that pretty quickly. I think the hardest part is trying to get the organizational structure right, or deciding we're going to do it within one organizational structure and I'm going to get it right. So maybe it's just in propulsion that we're going to do this reuse and we're going to have 100% reuse across propulsion. That's a legitimate approach, and we do see people starting with single organizations like that. So that's not an uncommon one. You can try and do it just on a single ECU. Sometimes means the same thing. But typically, I do see a single organization being an effective way of putting your foot in the water and testing it out. I will say that companies with fairly simple electronics are doing this and finding a great deal of return on it. So it doesn't need something as complex as an entire vehicle. It can be as simple as a next-gen electric motor for rear end on a vehicle. There's a lot of software that can be just reused in that mode. So it's across the board different ways I see people approaching it, but I can't say there's any one right way or wrong way, but the organization, making sure you have enough people in there to make the reuse worthwhile is great. And getting the buy-in across the organization is an absolute showstopper if you don't have it.
Okay.
Any other questions this time? Anything for Peter? Or?
I have one that's been typed in. So any recommendations on what to do after having everything in one monolithic global configuration as the 150% solution, and then moving to this approach? How to prune configurations to get them to a better starting point? Just talk more, please, about starting to do this when your starting point is one large 150% stream.
Yeah, so it's a great point. So the first thing that I see clients really sitting down and doing is understanding what their 5-year plan is for additional features and functionality. Those new variants are going to come from you looking ahead and understanding where you're going to be adding capability and making changes over time. That becomes your most important variant points that you have in that 150% BOM. You need to get those right. That's where that upfront design and approach to this will give you a lot of benefits in the future. And you have to decide how many variant points you want to have. It's easy to say I'm going to have as many as I want, but that gets really complicated fast. So trying to get the variant points to ones that are really going to add value and are going to be change areas for you, that's an important step. And then deciding over time, what is your implementation strategy? You notice what we were talking about when we say 150% BOM. It doesn't mean that exact same software is in every vehicle. You have that base one that doesn't have all the software. The top level thing has all the software in it, right? The platinum version or whatever has that. As I look at the mid-range, I look at the base, it doesn't have all that software in it, which is important because it's less memory requirements, performance requirements, etc. On the lower end model, so that you still get the cost savings across there. So it's important to think about how you're going to segment on the implementation of your code in your vehicles, as well as what you are doing as far as where the variant points are and what the value is going to be over time of defining those variants and taking advantage of it. I hope that's a little bit clearer. I do think that the idea of it not just being about variants, but about your implementation of it is really important. So the concept of, am I going to have just a single platform across all my battery electric vehicles? Do I then have a different variant that's for fuel cells or extended range? There's going to be some thoughts about how you plan to do that over time. And clearly, having a variant point between, ICE, an ICE vehicle versus some type of a EV vehicle is certainly, a clear variant point out there. And I think all the ADAS stuff that you saw, I think the examples Andy's put together are very realistic as far as, what are those new functions and features you're going to be adding to get to the point where we're finally getting to, level 4 autonomy.
Okay.
Yeah,
Peter?
so you saw in the ADAS example. I'm sorry? Can you hear me okay?
Yes, go ahead, Peter.
So I was just saying in the ADAS example that we saw in the demo, so you saw the basic ADAS system did not have the lane assist in it, but the full set of requirements and the mid-range set of requirements had the lane assist in there. So that's just one of those examples that that Brett was talking about.
Thank you. Well, Brett and Peter, it looks like that's it for the questions. I just wanted to let everybody know that if you have anything, that crosses your mind, anything you'd like clarification on or more information, you can email us at info@321gang.com. This concludes the presentation for today, and the session was recorded. It will be available for playback at 321gang.com under the Resources tab, and there's a lot of other nice videos that are up there as well, so feel free to watch anything you'd like. And thanks everybody for attending, and thanks to Brett and Peter for the presentation, and Andy.
Right.
Okay, bye-bye everyone.